Okay, hi and welcome to some video notes on 10.4, which we're going to call solving with square roots. Now, we've seen all of our properties of our radicals, specifically square roots. We've been saying radicals because they apply to all radicals, but we've been working specifically with square roots or a radical of 2. In doing that, we've prepared for kind of this day. We've worked our way up and know how to simplify and clean up and combine like terms and what like radicals are and what ones aren't. So the whole thing sets us up for solving. And we've solved before with linear functions and other forms of stuff. We can done with variables, but we've never done it with involving a square root yet. And remember, when we're solving, what are we looking for? There's a purpose to solving. And solving then, the purpose for is to find x-intercepts. So if we're looking at whatever function we're talking about, we say the word solving, we're going to be looking for where it intersects the x-axis, how many times it intersects the x-axis, and what's the x value that occurs at. In using these square roots, we also know that they're the inverse of a square. So that means that when we're solving a function, we're probably going to be solving a function with square roots that has a squared value. And maybe we haven't worked a lot with them in class, but we've been introduced to them. A function that has a squared value in it, if that's the largest term, is a quadratic. So that's why I drew a little quadratic here, just to kind of pull some of the pieces together. Do you need to know everything about quadratics? Absolutely not. What you need to know is if you've got an equation with a term that has it's 2 on it, that you're going to have to employ square roots possibly to solve it. Now, does it mean that solves all of them? No, this is just one piece, and in the next unit, you're going to see a lot more of that. But we're going to introduce it here. It's kind of like a little segue between the two. So now that we've got that down, how do we solve with square roots? There's one thing that's necessary to know that you can solve with square roots, right, is that there's no linear term, meaning that when we have this function that we're going to be given, or this equation, that it can't have any terms with an x in it. And as you look through all of our examples here, you'll notice that there's only one term that's squared, that there isn't another variable involved. So it's either x squared and there's no x, and it's n squared and there's no n. So there's no single or what we would call a linear term in there. And again, things that we'll talk more about. So with that being said, here's what we do. We go ahead and solve for the term that's squared, then we take the square roots of both sides, and then most importantly, we have to add a plus or minus. But let's remind ourselves, let's say I have a value of 4, and then I want to square a term that makes 4. What value can I square that makes 4? There are 2 terms that would work, a -2 and a +2. If we square either of those terms, they're both going to make 4. So there's a possible negative and a possible positive value that works. That's where this comes in. It accounts for the fact that there's either a negative value that might work and a positive value that might work. So we have to add that anytime that we're solving, and we take a square root in doing that. Okay, so now that we've got that down, let's go ahead and see what this looks like. So here is of the form, if we just happen to have an x squared and it's equal to 16, we can use square roots to find out what x is equal to. Remember, that's x squared. We don't know what x squared is equal to. It's equal to 16. What x value is equal to that? That's what we're going to find out. So what would we do? Well, we're going to take the square root of both sides. So by taking the square root of both sides, we see that these are going to go ahead and their inverses, they reduce out. So I'm going to clean this side up first. We're going to get x equals the square root of 16. Now this is where I want you to get in the habit of, and I'm going to make it green, adding a plus or minus. There's 2 possible versions that could occur here, a negative version and a positive version, if you will. Now 16 happens to be a perfect squared term. That's exactly what we want. We want to show it as 4 squared. Why? Because we can reduce it out. And so what we end up with, or the possible solutions, or x-coordinates for the x-intercepts, are going to be positive or negative, and negative 4. So we could write that another way, x equals 4 and x equals -4. That's the 2 possible x-coordinates for those intercepts, the x-intercepts that we're looking for. Okay, let's do that again. Let's take a look at this one. We've got x squared equals 81. Again, to solve this, to get down to x, find our x-intercepts, we're going to go ahead and take the square roots of both sides. Again, this square root and that square are going to reduce, right? They're inverses. I'm going to add a plus or minus here, and I'm going to be left with the square root of, I'm going to go ahead and take 81, because I know it's a perfect squared term, to 9 squared. Those are going to reduce out, so I find out that x is equal to plus or minus 9. You can leave it like that, but what it means is x equals 9 and x equals negative 9. Those are the two possible solutions. Again, we're solving with square roots, and that's how that looks. We found that the possible x-intercepts are at positive 9 and negative 9, right? And if they're intercepts, we know this. We know that the y-coordinate is 0 because they're intercepts. All right, well, let's take a look. Let's see if we add a constant to it. Well, now we've got something similar, but this time it's got a value that's not squared. How do we deal with that? Well, just like solving any other function that we've done so far, we're going to go ahead and isolate the part that we need to get to the x. So we're going to add 98 to both sides. We're going to be left with 2x equals positive 98. Now we're going to divide by 2. And if we divide by 2 there, we're going to be left with x squared on the left, and that's going to be equal to 49. At this point, it looks just like the last problem. So what are we going to do? Take a square root of both sides. I'm going to come up top here, and we're left with x equals plus or minus, don't forget to add that, right, the square root of 7 squared. Again, the square root and the square cancel, leaving us x equals plus or minus 7. Again, we can write that out as x equals 7 or negative 7, or you could even get fancy and say it's the intercepts 7 and negative 7 and 0. Those are the two possible solutions for this function, this quadratic function that we're looking at. Again, not knowing a lot about quadratics. All right, let's do that again. Let's go ahead and subtract 32 from both sides. We get 2g squared equals negative 32, and you're freaking out because there's a negative. That's okay. Don't let it get to you. We know how to deal with negatives and radicals now. All right, we're going to divide by 2 on both sides. G squared is going to be equal to negative 16. Again, square root both sides at this point. I'm going to move over here. So we're going to get g equals, don't forget your plus or minus, the square root of negative 16. Well, what do we do with a negative? Well, we know that that's an imaginary number. So that negative there, or the square root of negative 1 times 16, that square root of negative 1 there, is I. So let's change that part. So g equals, and we put I out front, right? It's multiplied to the front of the radical. So we put plus or minus I times the square root of 16. But we know square root of 16 is 4 squared. Or when we square root it, it's 4. So g equals plus or minus 4i, because it comes out front. And that's when we're done, because there's nothing left under the radical. So g equals positive plus or minus 4i. What does that mean? It means it's an imaginary number. It means it actually doesn't intersect the x-axis, but we'll talk more about that later. All right, let's look at one other type of example. What happens if we've got a whole expression that's squared with our x inside? And a lot of times when we've seen this before, we might want to multiply it out, but we're not going to. We're going to go ahead and take whatever term is squared that has our x in it, and we're going to square root it. So we're going to go ahead and take a square root of that expression, and we're going to do it to both sides, because whatever we do to one, we have to do to the other. Again, the square root and the square cancel, leaving us with x minus 5 on the left equals, we'll throw our plus or minus in there, the square root of 7. All we have to do now is move that 5 over. But this is where you got to pay attention. When we add 5 to both sides, this is plus or minus the radical term. It's not plus or minus 5, so this 5 is going to go in front. What this is going to look like is 5 plus or minus the square root of 7. Oddly, that's what it is. Let's write it out so we can really see what it means. It means this: x equals 5 plus the square root of 7 and 5 minus the square root of 7. That's what it means. Could we calculate that? Yeah, it's going to be a decimal, so we're going to stop there. But that's what it would look like. So let's try that one more time. And if we look at this one, same thing, except for notice our term with our x, it's squared, that we want to get to, has a negative 25 on it. So we're going to go ahead and add that 25 to the other side first. So we're left with x plus 3 squared equals positive 25. Square root both sides. Okay, we're going to be left with x plus 3 equals plus or minus, don't forget your plus or minus, the square root of 25. Let's go ahead and change that to 5 because I think we're good enough to know that now. So we got plus or minus 5. And now we're going to take that 3 and subtract it to the other side. So it's going to be x equals negative 3 plus or minus 5. Again, we can stop there, but let's write it out and see what that really means. It means x equals negative 3 plus 5 and x equals negative 3 minus 5. Or, better said, x equals 2 and x equals negative 8. Or, if you wanted to take it a step farther, 2, 0, and 8, 0. Negative 8, 0 as intercepts. All right. Again, why don't we expand the parentheses? Because if we do, we get that linear term and we don't know how to solve it. But there's the notes. You should see kind of all the variant forms of how we can solve with radicals. Again, it deals with quadratics. We're moving into quadratics, so this is a nice little segue. You see how to do it if we have a constant or if it's in a term that's the whole thing is, or the expression is squared. So you should be good to go. We'll see you in class. Don't forget, there will be example videos on this portion here. Look for those.